Hey everyone, let's talk about a piece of technology you probably use dozens, maybe even hundreds of times a day, without even thinking about it. It's called natural language processing, or NLP for short. And honestly, it's the invisible interpreter that's quietly running so much of our digital world.
So, think about this for a second. What could your email spam filter, the GPS that gives you voice directions, and one of those customer service chatbots possibly have in common? I mean, they seem like completely different things, right? But they're all connected by one really powerful behind-the-scenes technology.
Well, the answer comes down to solving a really fundamental communication problem. A problem that exists between us, humans, and the incredibly powerful but, well, very literal machines we depend on every single day. And here's the core of that challenge. You know, our language, human language, is messy. It's packed with context and slang and sarcasm and all sorts of nuance. But computers, they speak in structured, logical data. They need total precision. So how on earth do we bridge that massive gap? That bridge? That's natural language processing. NLP is this amazing field of AI that's all about giving computers the ability to read, understand, and actually derive meaning from our language. It's the interpreter that translates our messy human thoughts into structured commands that a machine can finally understand and execute. But how does this actually work? I mean, really, how do you teach a machine to understand something as complicated as language? Let's pull back the curtain a little bit and see how this digital interpreter is actually trained. You know, the easiest way to think about it is like teaching a child to read. You don't just hand them a huge novel on day one, right? No, you start with letters, then words, and you slowly build up the complexity. The process for a machine is actually pretty similar. It's all about breaking our language down into small, manageable pieces. This whole process is called text pre-processing. First, the machine just breaks a chunk of text into individual sentences. Then, it breaks those sentences into individual words, which we call tokens. After that, it gets rid of all the common filler words like the, and is. And finally, it tries to figure out the root of each important word to get to its core meaning.
And that second step, tokenization, is so important. It is the absolute foundation. Before a machine could even begin to understand a sentence, it has to be able to identify the individual words. It's kind of like us seeing the spaces between words on a page.
Okay, so next, a machine needs to figure out that running, runs, and ran are all related. Now, there's a crude way to do this called stemming, which basically just chops off the word endings. But then there's lemmatization, which is way smarter. It uses a dictionary to find the true root word. So it's smart enough to know that the root of better is actually good. And that's a huge leap in understanding real meaning.
All right, so we've covered a little bit of the how. Now for the really fun part. Let's explore the where, because NLP is already all over your world, probably in ways you don't even realize. I mean it. These tools are everywhere. Your phone's autocorrect or predictive text? That's NLP. The spam filter that keeps your inbox from overflowing? Yep, that's NLP analyzing language patterns. And when you ask Siri or Alexa for the weather, you are literally speaking directly to a natural language processing model. But the impact here goes way beyond just daily convenience. Get a load of this number, 360,000. That is how many hours of work JP Chase saved in 1 year, all by using an NLP platform to review super complex loan agreements. A task that used to take an army of lawyers can now be done in seconds. That just shows you the incredible, transformative power we're talking about. And the applications get even more profound. In healthcare, NLP can analyze a doctor's clinical notes to match patients with life-saving medical trials. In finance, it scans millions of messages to detect fraud. And in business, it can instantly gauge how the public feels about a new product just by analyzing thousands of online reviews. It's pretty incredible. So, with all of this amazing power to understand and act on human language, we absolutely have to talk about the ethical challenges. Because when a machine learns to speak our language, well, it can also learn our flaws. This is a fundamental truth for all of AI, but it's especially true for NLP. A model can only learn from the text data we feed it. And where does that data come from? A lot of it comes from the internet, which, as we all know, is full of our own human and societal biases. And that bias can creep in at pretty much any stage. It can be baked right into the data from the start, reinforcing harmful stereotypes. It can happen during testing if the model isn't evaluated on a truly diverse group of people. And it can pop up when a model is used for something it wasn't even designed for.
On top of all that, you'd have massive privacy concerns, since these models are often processing our most sensitive personal information.
This all leads to a really difficult question. If an AI model ends up being biased, who's responsible? Is it the fault of the data, the developers who built it, or is it a reflection of the society that created the data in the first place? There are no easy answers here, but it is a critical conversation we need to be having as this technology becomes more and more powerful.
So, keeping all of those challenges in mind, what's next for NLP? The pace of innovation is just staggering, and it's promising an even more seamless world of human-machine interaction. We're definitely heading towards smarter search engines that give you direct, precise answers instead of just a list of links. We're also seeing a huge push for a more inclusive NLP that can support hundreds of different languages, not just the major ones. And of course, the ultimate goal is just more natural interaction, where we can have truly human-like conversations with machines that understand context and nuance. And that leaves us with one final thought to chew on. You could argue that language is the very thing that makes us human. So, as we build machines that are getting better and better at mastering this fundamental trait, maybe the most important question isn't what they will end up saying to us, but what we will choose to say to them.